Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we'll solve another question from Leetcode altogether. So let's get started. Yeah, so today's question is minimum operations to make a binary array equals to 1. So what is given to us? They have given a binary array nums to us. So binary array means it consists of only 0 and 1s, as simple as that. And you can do the following operations on the array any number of times, possibly 0. You can't, maybe you are not able to do, maybe you are not want to do any operations altogether, and also not able to do also, that is also a case. And choose any three what you can do on a one operations, choose any three consecutive elements. Consecutive means one after another, any three consecutive elements from the array, and flip all of them, right. You, so flip means if that is 0 then it is going to be 1, and if it is 1 then that is going to be 0. So flipping an element means changing its value from 0 to 1 and from 1 to 0. That is, if it is 0 then it is going to be changed to 1 and 1 to 0. Return the minimum number of operations required to make all the elements in nums equals to 1s. To make all the elements in nums equals to 1s. So we have to say what is the minimum number of operations we have to perform to make all the elements in nums equals to 1, right? The question is very simple. Like, now if we are not able to do any operations altogether, then we can return a -1, right? So now what we can think, like you can keep an window of size 3, and you can keep on like checking in this window if all are 1, if on the window you are considering all are 1, or let's suppose what you can do, if, so that is also one approach which I was stating. If the particular window of 3 size, if all are 1, then you are not going to perform any operations altogether. If any of them is 0, then starting from that index you can perform an operations of flipping. You have to flip that elements, that's the for sure. And now starting from that you can flip the elements, so now if you are iterating over the array, if you are standing to a particular index, and if that index is 1, do you do any flipping on that? Do you do any flipping? No, right? Because we are greedy. We have to return the minimum number of operations. We don't want to do an operations to an element which is already set to 1, ones. And if it is 0, then for sure you don't have any liability to skip that elements. You have to perform an operations on this particular index. You have to perform. So if you perform these operations, then considering this index, a window of length 3 is going to be flipped. For sure. So that is the strictness we have to follow. If we are flipping an index, so considering that we have to consecutively flip all the 3 elements. Right? So on initial go, I thought that can be solved with DP or another approach, but after like thinking for a while, and my wife also thought on the directions on the same, like, because we have the rigidity, if a particular index is altogether 0, like if a particular bit is not altogether set, then you are bound to take operations to this particular index to a sliding window size of 3. You don't have any liability to choose to do any other things, right? So that is one case. And if that is 1 altogether, so you are not going to take any operation, because we are greedy altogether. So now the question is as simple as that. If you follow this route only, you are going to get an AC. You are going to get an accepted. So that's it, right? So I'm not going to explain any whiteboarding to this particular question, because that is as simple as that. So what we have to do now let me just you guys iterate over the code altogether. So I have defined our length nums, and I am starting our I pointer from 0, and initially we have answer to of 0, and I am running a while loop. So this while, now if the particular index where you are standing, if it is a 0, then you have to perform certain operations, right? And if it is altogether 1, then as I told you, you are greedy. You are not doing any changes, because considering this, why you want to flip the bits? Because that is altogether 1. So that is basically stating that still this index to its left, you have already done its processing. So don't need to do anything, right? And if it is 0, so that means you have to perform an operation. So like on the else case, we are doing nothing. We are just iterating our I++, no matter if it is if or else. And if it is an if case, then what? Then you are checking, like you have to select 3 consecutive elements altogether. So if starting from this index, if you don't have the liability to expand of window size of 3, starting from this, if you can't consider a window of size 3, then you are not altogether able to perform the operations. You are not altogether able to perform the operations. So that's the checks we have to put. If starting from I index, do we have another 2 elements to its right? So that means I plus 2 is less than n. So do we have another 2 elements to perform the operations to its right? If yes, then we are doing what? We are increasing our answer because we are going to perform an operations. So we have increased our answer and starting a j pointer. So this j loops is very simple. It is going to run 3 times only. So we are starting a j loop from index I to 3 elements, I to I plus 3, as simple as that. And what we are doing, we are just changing nums of j to zod of 1. So that means if that is a set bit, it is going to be answered, and if it is not set bit, it is going to be set. So that zod is going to be taken care. So you know, right, it's the zod truth table. 1 1 is 0, 0 1 is 1, 1 0 is 1, and 0 0 is 0. So if it is 0, then with zod 1 it is going to be set, and if it is 1, then 1 zod 1 is going to be set to 0, right? As simple as that. So we are basically done the flipping. And if we are not able to take a window of size 3 considering this, so let's suppose on this test cases, after you flip this, it's become 1 0 0. Now from 0 again you flip this, so this one becomes 0, and when you reach this one, it is altogether turned to 0 by flipping of the previous elements. So now standing at index this 0, you are not able to consider a window of size 3. So this 0 is altogether not going to be set. You don't perform any operations to this particular index. So that is the edge case. So if you are not able to consider a block of size 3, then you are not able to allow to perform any operations. If that is so, then on that case we are returning -1, because on the question stated, if you are not able to, if it is impossible to make the entire array to be all 1, then we should return the -1, right? So this is very straightforward question, I have to say. But yeah, like to identify that, we just have to implement the brute, and brute is altogether going to be proved as a very optimal solution. So that actually I feel the challenging part on this question. So we have to just write the brute, and brute is altogether the most optimal solution for this question, right? So as usual, so we do for every questions. What is the time complexity, guys? The time complexity, I think, is very simple. We are running a n loop in the outer, and inside n loop, if it is a non-set bit, so then on that case we are iterating altogether 3 times. We are running this j loops 3 times of size 3. So the time complexity is big of 3n. And what is the space complexity? Do you think we are using any extra space? No, right? Everything we are doing in place. So we are moderating the nums array, we are changing the nums array and all other variables. So the space complexity on this case of big of 1. So yeah, it is as simple as that. So the time complexity for this question is big of 3n, and space complexity is big of 1. So like as I already told, like on every video, so if you guys are able to understand my explanations, so please do subscribe to our channels, and please share the video to the people who are preparing for their top product based companies. So please do, and please turn on the notifications so when you are going to be live with our next video. So let's meet tomorrow, guys. Bye for today.